Hi guys, hope you're all doing well. Some of you guys saw a video last week similar to this one. For those of you that did not, I mentioned to them, please use this as a way to not only learn today's material, but also get a sense of what class will be like when I do return. Again, thank you for your patience, your understanding, and I look forward to seeing you guys very soon. Today's do now is to take out our materials, again, a pencil and a notebook. And in Google Classroom, if this video is not already playing, you can find the 2-6 lesson, Connect Proportional Relationships and Slope. And just a reminder, while the video is playing, take notes in your notebook to reference later. Okay, so this is our second lesson. It's 2-6 called Connect Proportional Relationships, what we learned last week, and this new word for 8th grade called slope. All right, so we're going to see this in a graph today, as well as this formula. These are our two big ways of calculating slope. So let's go to our objective, and this will hopefully make a lot more sense at the end of this video. Students will be able to, you'll be able to find the slope of a line using different strategies, and we're going to use slope as our vocab word today. You're also going to interpret a slope in context and relate it to the steepness on a graph. All right, so we've finished our do now. We're going to use similar triangles. We're going to find slope via the slope formula, and then we'll let you guys pick your choice as to what you want to do. Okay, and then we'll set you up with your asynchronous work. There we go. So this is the standard. It's a little bit different than last week. 8EE6. Use similar triangles to explain why the slope, which is referred to as m, why the slope m is the same between any two distinct points on a non-vertical line in the coordinate plane. There's a lot to that. But the big part, slope is the same between any 2 points. Derive the equation y equals mx for a line through the origin, and the equation y equals mx plus b for a line intercepting the vertical axis at b. We're not going to worry about that second half. That comes much later on, but we're really going to use this first part today. All right, so I think we're going to start with the definition of slope, and if you're like, what? This makes no sense, we're going to come back to it at the end of this video and hopefully like, all right, I kind of get this. Yeah, slope is huge, guys. We're going to spend a lot of time at the beginning of the year on slope. So today's a really important day to focus, write some good notes, and think of any questions you have to pass along. All right, so what is slope? Slope is a ratio. So we talked a lot about fractions or a ratio last week. And it's going to describe the steepness of a line. So steepness meaning, think about it like a mountain is very, very steep. If you were to ski down a mountain, that is very steep. Whereas if you're on a flat piece of land, like the SBA field, there's no steepness. It's very flat. So slope is calculated by the vertical change, vertical meaning up and down, over the horizontal change. Side to side is horizontal, side to side. All right, so going to make more sense when we see an example. Another way of saying vertical change is rise, because you think about when a sun rises, it goes from down to up, right? So vertical change meaning up and down the rise of the line. And when you run left to right or horizontally, side to side. So we're going to think about slope as another way of saying it's the rise, the vertical change, over the horizontal change, the run. Okay. And I'm going to leave this up here for a second. Another word for slope. This looks a lot the same. It's just another way of saying slope, the rate of change. Rate of change is the ratio, vertical change, over the horizontal change between any 2 points on the graph of the function. All right, so let's get into these two big ideas, okay? All right, We're going to do 3 problems today out of the 6 that give a really good sample of this lesson. Again, our objectives of today, the section number, the date, my name, all in your notebook. I copied the graph just because I'm going to show you something that I can't write on here that I want to write on my paper. So you do not need to copy the graph. That is just for me to show you what we're about to do. All right, let's go. The graph shows the relationship between the time and the number of soda bottles a machine can make. Use the points 2, 60, which is right here, this blue dot, and 4, 120 to find the number of soda bottles the machine can make each minute. Sounds like a unit rate to me. But we're going to calculate the unit rate a little differently than we did last week to help you guys when we start not proportional relationships next week. All right, so think of this as a way to focus and a new way to calculate unit rate that'll be really helpful next week, as well as this week. All right. The first way I'm going to have you calculate this unit rate is by drawing similar triangles. What does that mean? You saw that in our picture over here, there was the rise, how much the line goes up, over the run. So I'm going to make a similar a triangle out of this graph, which I'm going to do over here. And in that, we're going to calculate its unit rate. So let's do this. Let's do the rise we're going to do over the run. The vertical change over the horizontal change. I'm going to do the rise in pink. I'll do the run, the horizontal change in yellow. And let's get to it. Okay. So when I make a triangle between 2 points, I'm going to start with the lower point. I'm going to draw a line up. Kind of meets right here. So up. And the run is going to be side to side. So I'm looking to connect the 2 points with a triangle. And then what I'm going to do is I'm going to count these lengths. The rise length and then the run length. Okay. So all to find this keyword called slope. So a lot of people will tell me this is 2 units. And I want you to think about why it's not 2 units, even though it's 2 spaces. So take a second, think about that. Why is it not 2? And if you know why it's not 2, think of what number it is. Okay. So if you see here, it looks like this point says there's 60 soda bottles. And this point up here says there's 120 soda bottles. So the change of that is not 2, right? It's kind of like each of this is 60, 90, 120. So every time you jump up a block, it's kind of like counting 30 bottles. So we're going to count 60 to 90 is 30. And then 90 to 120 is another 30. So this is actually a difference of, or a change of 60 bottles, right? 30 plus 30. Each square represents 30 units. When I'm looking side to side, I'm focused on the minutes over here. So it's not 60 minutes because if you look at these little boxes here, each unit is 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes. Each block is counting 1. So now this line in yellow is actually 2. It corresponds to 2 minutes. So when I make my unit rate, or my slope, which is represented by the letter M, I'm going to say that the rise is 60 bottles, or the change is 60 bottles are made every 2 minute. And then you're going to want to calculate the unit rate, because that's what the question's asking. How many bottles does the machine make each minute? Not each 2 minutes, but each minute. So unit rate, remember, 1 is on the bottom. Divide by 2. This is all the last week's material. Divide by 2 right now. And 60 divided by 2 is 30 bottles. Here's our unit rate. And we're going to put that answer in. Check it out. We got it. Now you might be asking a really good question. Mr. Gallucci, why the heck did you do all of this rise over run? It's kind of confusing. I didn't get really a lot of it. Why did you do all that when we could have just picked 1 point and got it? That's a really great question. But what I kind of want to make you aware of is starting like next week, you're not going to be able to just pick 1 point and do this and get the right answer, because it's not going to be proportional. Remember, proportional means it starts at 0, 0. So when the line doesn't start here, you can't just pick 1 point like we did last week. You have to either use similar triangles or the way we're going to do the next problem. So a couple seconds to think about that as we make our way to problem number 2. We'll zoom out a little here. Whoops. Okay. So that was kind of the rise over the run. So you can kind of see that each of these does that, the rise over the run. Let me actually take this time. I'm going to stay on this one because there's an important part to it here, which is, if I can get this down. I want to zoom in just 1 sec here. And all right, I can't get rid of that. One thing you might say is, well, Mr. Gallucci, they gave us those 2 points. What if we had to pick like these 2 points and make a really bigger triangle? All right, so we said each block, Mr. Gallucci, was 30 bottles. So 30, 60, 90, 120, 150. That's 150 bottles, Mr. Gallucci. It's a different unit rate. Or is it? Let's calculate the run, the side to side. That's 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. This is why they're called similar triangles. You can make any triangle, and guess what? If I do that here, 150 bottles over 5 minutes, I'm going to exclude the labels for right now. I calculate the unit rate, 1 minute, with divide by 5. This might be worth watching over again. There's a lot happening. Divide by 5. 5 divided by 5 is 1. 150 divided by 5 is 30 bottles. Look at that. No matter how big or small the triangle is, the slope is the same. No matter how big or small the triangle is, the slope is the same. Huge, huge piece in math. So keep that in mind as we move forward. Because a lot of students will get, say, I don't know which 2 points to pick. It doesn't matter. As long as you calculate it right, count those blocks right, it all works out to be the same. All right. Enough of that problem, Mr. Gallucci. Let's move on. All right. We are going to draw a nice big line, and we're going to call this number 2. All right, and it says, number 2, using the slope formula. You don't know that yet. I'm going to teach you that right now. Find the slope of the line through the point 0, 0, and 3, 9 using a pencil and paper. Explain how you can use mental math to find the slope of the line. Okay, so let me show you the slope formula. It looks pretty scary. It's this guy right here. Okay, so I'm going to write that down on my paper. It's huge in math, so please write it down with me. Again, this is called the slope formula. And I'm going to show you what it is, how to use it, and go from there. Okay, so let's do a little zoom in. I need to see this. Okay, and in the problem, they give us 2 coordinate points. They give us 0, 0, and they give us 3, 9. Something to always remember in a coordinate point, x comes first, y comes second, x comes first, y comes second. And because there's 2 of these points, I'm going to label the first one I see x1, y1. I'm going to label the second point I see x2, y2. And now maybe you can see what these actually mean here. First point x, second point y. This is the first x I see, x1. Second x I see, first y I see, y1. Second x, x2. Second y, y2. And then what we're going to do is we're going to plug those numbers into the slope formula. Right, so first comes y2, which is this one. So we're going to plug in 9 first. Keep all the colors together. We're going to plug y1 in this. The formula says subtract, so I put a subtraction. y1 is the 0, 0. 9 minus 0 over, let's see, x2 is the number 3. Minus the last number, x1, which is also 0. You've got to make sure, keep in mind as you're doing these, you've got to keep them in the right order. That way you don't make any mistakes. And let's calculate it. So the slope of this line is 9 over 3. Or you could simplify that. Divide by 3. Divide by 3. Remember simplifying from last year. You can't see that. Sorry about that, guys. So what I did, 9 minus 0 is 9. 3 minus 0 is 3. And to simplify, I divide both the top and the bottom by 3 to get 3 over 1 is our slope. And if I made a quick graph, can I do it? Let's see. Do I have enough space? Let's see if I can. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see if I can do it like this. I want to show you something really quick. If I put these 2 points on a graph, 1, 2, 3, you don't have to do this, just follow along. 2, 3, so that's 2, 4, I'm running out of space here. 6, 8, 10 would be way up here. So the 2 points that we had from the original problem was 0, 0, the origin, right where my finger is, and then 1, 2, 3, 3, comma 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to show you that the slope of this is, the line is going to rise 3 and it's going to run 1. So watch this. Here's a similar triangle. It's going to rise 1 unit, 2 units, 3, and it's going to run 1. Just like it did last problem. Rise 1, 2, 3, run 1. Rise 1, 2, 3, run 1. So you can see that slope is the vertical change is 3, the horizontal change is 1. Let's do it as 3 over 1. That's what it means by simplified fraction, is when we simplified right here. And let's check our answer. What? Oh, they're being picky. Although your answer is equal to the correct answer, it is not in the correct form. So because 3 divided by 1, they're being very picky here, guys. They just want it 3 divided by 1, or 3 over 1 is the same as 3. They just want it like that. We had the right answer. We did everything right. They're just being picky. Okay, so I'm going to change the camera or the zoom. Please pause the video, copy anything you need to down before we move on to the next one in a minute. All right, last question, guys. Here we go. Very simple question. Find the slope of the line. So here's what I mean by it's your choice. At this point, I showed you 2 ways to do this. Whoops. Find the slope of this line. Again, they want it as either an integer or a simplified fraction, so they're being picky here. You can do one of 2 ways. You can calculate the rise over the run. You can count the grids, or you can use the slope formula. Number 1 was the grid way. Number 2, the slope formula. So maybe take a minute, try to do it on your own, see what you think this slope would be. Okay, let's go for it. Since I don't have the graph drawn, this is one of the ways why slope formula is very convenient. I'm going to use the slope formula. Because if you don't have it on a graph, or it's on the computer and it's hard to see or draw, it's pretty helpful to use the slope formula. All right, so here's what I'm going to do. I see they label 2 points here. I'm going to find the coordinates of those 2 points. This first one I see, it goes -1, -2, -3. And then it goes up 1, 2, 3, 4, 5, 6. So that would be -3, 6. And this other coordinate goes over +1 and up 2 units. Something I always do is to help myself is I write down the slope formula and then I write down x1, y1, x2, y2. And then I'm going to plug them in as I see them. So let's see. Y2 is the number 2, minus y1 is the number 6, x2 is 1 minus x1, which is negative 3. So be careful here. This is where a lot of students trip up. All right, 2 minus 6. 2 minus 6 is negative 4. Again, use a calculator for this. If you're unsure, or check your work. 2 take away 6 is negative 4. And then I know Mr. DeFranzo, Ms. Ferranti always use some little helpful tips to remember here. 1 take away negative 3. A lot of teachers will say, keep, change, change. Keep the 1, change the subtraction to plus, change the negative to plus. So this is a much easier problem now. It's 1 plus positive 3. 1 plus positive 3 is positive 4. We can simplify this, we can simplify this fraction. If we divide both the top and the bottom by 4, it becomes negative 1 over positive 1. Again, that would be divide the top by 4. This is simplifying, divide the bottom by 4. And then one more step. They were picky last time, they're going to be picky again. If the fraction is over 1, you can make it an integer or whole number by just keeping the top. Let's see if we got this right. This is negative 1. Negative 1. Fantastic. All right, so now take a minute, copy down anything you need to. One thing I will mention while you're doing that, if you notice the slope of this line is negative, you can kind of always tell when the slope's going to be negative because look at the line goes down, right? Here, we had a positive slope, the line's going up. Even here, when I drew the graph, it was a positive number, that line was going up. If it's a negative slope, the line's going to be going down from left to right. Okay. We made it through our second video, guys. So let's go back. Slope, the way you're going to calculate slope is the vertical change, the rise, over the horizontal change, the run. You can also use the slope formula if you don't like that way on a graph. And that's the same as rate of change. So hopefully we accomplished our goal today. We know how to find the slope of a line using different strategies. And moving forward, we're going to interpret the slope in context. And we're going to see the bigger the number, the steeper the line. This one I think we need a little more time on, but we should all be a little bit better in finding the slope of a line using different strategies. The rise over run, the slope formula. Thank you guys so much for listening. One more video lesson and then Mr. G is back the next week. So keep up the good work. I know you're doing it, and I will see you soon.